I'm going to do a different approach to the focus directrix construction of our parabola. First, let me create the focus distance f from the x-axis and the directrix parallel distance f from the x-axis below it. But now I'm going to draw a circle which passes through the focus and which is tangential to the directrix. The centre of that circle will be the same distance from the focus and from the directrix, and we'll trace out a parabola. But in order to use the locus, I need a parameter to vary. So I'm going to put in the radius of the circle. Now I can create locus as the radius varies, and I get my parabola. Let me just check the equation of that parabola. And it is what I expected it to be. Now let's just look at the parametric equations. We see here the equation for both the x and for the y, and they involve both f and r. Now, what would have happened if instead of varying the radius, I'd varied the other parameter, which was f? Change the color of that parabola, and let's look at what new curve I would get if I varied f, keeping r constant. So I get a different curve. And here, let me just vary f, and we can see here's keeping the radius constant, and the center then follows that new curve. If we look at the parametric equations of that new curve, we find that they are the same. The only difference between the curves is which parameter you vary. In one case, we're varying r. In another case, we're varying f. If we look at the implicit equation of the curve, then we find that is different because we have eliminated a different parameter from the parametric equations. We see in one case we have a y-squared term, in the other case we do not have a y-squared term. One is a parabola, the other is an ellipse.